Hello, good morning. Yeah. So today onwards I have to take the daily classes. If I available in Hyderabad, daily I have to take because now only we took so many days that mathematical methods of physics. Not like that, but classical mechanics I have to take the daily only. Don't worry. If you have any friends, you have to inform to your friends also, right? uh, why I am informing you know, maybe in the July one notification will come based on our syllabus of whatever I am teaching, those things are. If you have to take the CSR and GATE, you have to get help in that exam. So that's why I am informing to you, right? So today we have to discuss about the applications of the low range transformations. Yesterday we discussed about the low range transformation. We derived the low range transformation equations. Those low range transformation equations we also call it as a space time coordinate system also. Space time coordinates also we have to space time transformations also, because the space is coordinate is in terms of the time and time coordinates is in terms of the space is there. That is why we call it as a space time transformation also we call it as. Now today onwards we have to see the application, that is the first application is simultaneity. What is the simultaneity? If the two objects at same time if you have to observe, then that we call it as a simultaneity. The law of simultaneity, how we have to explain the law of simultaneity once you have to see. First you have to take the one frame of reference you have to consider. Here I am considering a one frame of reference. I am considering one person you have to take, this is one person, right? So in this person, once you have to see, maybe this is the A frame, you have to consider the A frame. Now the center of this person, this is the center of that. The left hand side is left side and the right frame is right side. I have to take that person. Now you have to see one sun is there, this sun is illuminating the sun. Which one we have to consider? It is a sun. This sun is illuminating here, sun is illuminating, right? So this sun is moving with velocity, with how much velocity is moving? With velocity in the right side is moving with velocity c, in the left side is moving with velocity c, in the left side also is moving with velocity c. From the center to here, what is the distance? L distance is there. From the center to here, this is also distance, L distance is there, clear. So how much distance is there? L distance is there. One person is here, that is the person B person is here, so that person is B person. So is here, that person is observing, this is the person is here, B person is moving with velocity v. So this is the B frame. Now another frame of the person. Now you have to concerning that, how we have to concern, once you have to see here what will happen, you have to take. Now once again you listen. First sun is there, the sun is going with velocity c in this direction, the light ray is going the velocity c in this direction, left side and right side, so going the velocity in this direction. Now at the center I am taking the center, A frame is there, that A frame is there, in where is there A frame? So A frame in that observer is sitting in the A frame. Concerning the A frame I am observing, suppose you have to take the frame A you have to take and you have to observe it. So what is the time taken for left side? Time taken to going to the left side, TL is equal to length is divided by velocity. Time is equal to length is divided by velocity. Similarly, the time taken to going the particle into the right side, T right is equal to, this is also L by C. TL is equal to TR is equal to also L by C. So therefore what we have to write here, so left side time taking to the particle is equal to right side time taking to the particle TL is equal to TR. That's why those two events can occur. The A frame is in which frame? Simultaneity or simultaneous. Simultaneous. Which one it is? These are simultaneous. Clear? So, this is the first one we have to discuss here. For left side the same time we are taking, for right side also same time we are taking. TL is equal to L by C, TR is equal to also L by C. Therefore, TL is equal to TR. That is why this one we call it as a simultaneous one, right. Now, not only this one, if you have to consider about the B frame, you have to consider. You consider about the B frame. If you consider about the B frame, right, how we have to consider about the B frame once you have to see here. So, this is the center, you have to take a center, this one is the center you have to consider. This length is L dash, this length is also L dash you have to take here. Now, the sun is there, sun is there here, is the sun, is illuminating the sun. Now, is moving with velocity c in this direction, it is going with the c in this direction, it is going with the c velocity, right. The person is going with the c velocity. Now, once you have to see here, so in the left side, you have to make it as this particle is moving with velocity v here. In the right side also you have to take this particle is moving with velocity B frame, so moving with velocity v only. So, this is the right side and this one is the left side, clear. The right side is moving with velocity, so v, and the left side also is moving with velocity v only. Now, once you have to take here B observer is there, suppose you have to take where it is, this is the A person, where he is sitting here. So, is sitting A person is sitting here, right. Now, you have to see the B person, right, person B you have to see. So, this person B is moving with velocity v, right. Now, you have to concerning through the B person you have to observe, how we have to observe, once you have to see here how we have to observe. So, concerning the B frame you have to take here what is that velocity, if you have to, the c velocity is there, this velocity is going to the against that one. So, that is why we have to take this complete velocity is c plus v, c plus v. Here both are going the same direction. So, that is why you have to take it as a c minus v, you have to consider as a c minus v, velocities are c minus, the resultant velocity here you have to take it as a c minus v, the resultant velocity here you have to consider as a c plus v, clear. Now, you have to observe for the time taken for the left side of the system is equal to L dash is divided by which one we have to take, L dash is divided by c plus v, velocity is c plus v, right side is equal to L dash is divided by c minus v. Now, you have to observe this one is not equal to this one is not equal to this one, because here c plus v is there, here c minus v is there. Therefore, TL is not equal to TR, left side of the time taking of the system is not equal to the right side of the time taking of the not system. Therefore, what we have to write? So, these are not simultaneous. Which one we have to take it as a, these are a not simultaneous, these are not simultaneous. Therefore, what we have to write? We have to write there, therefore, simultaneous conclusion, I am taking the conclusion. Therefore, what we have to write? Simultaneity depends on the frame of reference. Therefore, simultaneity depends on the whom? The simultaneity depends on the frame of reference. frame of simultaneity depends on the frame of reference. If you have to take a, if you have to consider simultaneity, therefore the simultaneity depends on the frame of reference. If you have to consider A frame, you are getting the simultaneous. If you have to consider the B frame, you are not going to get the simultaneous. Therefore simultaneity depends on the frame of reference. What is the main conclusion? The simultaneity depends on the frame of reference. Clear? Now you have to see, consider the two events occurring at two different points x1 and x2. Suppose if you have to take a S frame, you have to consider, this is the S frame, you have to consider, here one event is there, here one more event is there. So that a position of this event is x1, the position of event is x2, this is the event 1, this one is event 2. Now you have to see, consider the two events are occurring at two different points x1 and x2 at times. So which time it is? It is the t1 time is event 1 is occurring, in t2 time event 2 is occurring in the inertial system S frame. Similarly, if you have to take S dash frame, you have to consider here, what you have to consider? S dash frame you have to consider. This S dash frame is moving with velocity v with respect to S. Similarly, t1 dash and t2 dash be the times at which the two events are observed to occur with the respect to S dash frame. With respect to S dash frame, those events time when they are observing t1 dash and t2 dash they are observing. Clear? So with respect to S dash frame, therefore what we have to write? So the event 1 once you have to see, with respect to S frame, the event 1 coordinates we have to write. The event 1 coordinates are x1, y1, x1, y1, z1. We have to take it as a x1 comma y1 comma z1 comma t1. Event 2 if you have to see, what is that point? X2 comma y2 comma z2 comma t2 in event 2, right? This is the event 1 and event 2 you have to take. But the similarly, if you have to consider here S dash frame, that event 1 once you have to see, what is that point? x1 dash, y1 dash, y1 dash, z1 dash, the time is t1 dash is there. In the event 2, what is that coordinate is equal to x2 dash, y2 dash, z2 dash, t2 dash is there in the event 2. So therefore from the event 1 we have to write the coordinates, event 2 also we have to write the coordinates. So therefore from the event 1 and event 2 we wrote the coordinates, event 1 x1 coordinate x1, y1, z1, t1 in the S frame, and event 2 has x2, y2, z2, t2 in S frame only. So now corresponding to S dash frame, the event 1 occur x1 dash, y1 dash, z1 dash, t1 dash. Event 2 occur x2 dash, y2 dash, z2 dash, t2 dash is occurring the event 2. Similarly, so what we have to write here once you have to see, we know the thing according to the low range transformations, we know the low range transformations. What are the low range transformations? Right, once you have to see the low range transformations. From the low range transformations, x dash is equal to x minus vt is divided by square root of 1 minus v square by c square. This is the low range transformation. But you know gamma is equal to one factor, that factor is equal to 1 by 1 minus v square by c square. Therefore what we have to write? x dash is equal to x minus Vt is divided by means you have to write the gamma in. Similarly, t dash is equal to, so t dash is equal to, which one we have to write here, gamma into, so gamma into t minus Vx by c square. These two expressions we have to use and we have to take the simultaneous equations we have to derive. Once you have to see here, so what we have to write concerning this x dash is equal to gamma into x minus Vt. So therefore what we have to write, x1 dash is equal to gamma into x1 minus Vt1, x1 minus Vt1, x2 dash is equal to gamma into x2 minus Vt1, x2 dash is equal to gamma into x2 minus Vt1 we have to write. Similarly, what we have to take, so t dash is equal to gamma into t minus Vx by c square, gamma into t minus Vx by c square. Therefore, t1 dash is equal to gamma into t1 minus Vx1 by c square. Therefore, t2 dash is equal to gamma into t2 minus Vx2 by c square, Vx2 by c square. Therefore, by using this, what we have to take here, once you have to take these two equations, once you have to take, so therefore x2 dash minus x1 dash is equal to, x2 dash minus x1 dash is equal to, gamma you have to take the common, x2 minus x1 into minus v you have to take the common, t2 minus t1, t2 minus t1. So therefore what we have to write, once you have to take in this box, this expression is very very important expression, x2 dash minus x1 dash is equal to gamma into x2 minus x1 minus v into t2 minus t1. This expression we also take it as delta x dash is equal to gamma into delta x minus v into delta t, also we have to write delta x dash is equal to gamma into delta x minus v into delta t, also we have to take. And similarly which one we have to, you have to consider these two expressions, you able to write t2 dash minus t1 dash is equal to gamma into t2 minus t1, gamma into t2 minus t1 minus v by c square into x2 minus x1, x2 minus x1 minus v by c square into x2 minus x1 we have to write. So this is also very very important equation, once you have to confirm the simultaneity. So therefore if you have to take delta t dash is equal to gamma into, which one we have to take, t2 minus t1 is equal to delta t minus v by c square into x2 minus x1 is equal to delta x we are taking. Clear? Delta t dash is equal to gamma into delta t minus v by c square into delta x we are writing. So now once you have to take these two equations, from these two equations we have to conclude these two equations are very very important equations. You have to keep these two equations. Based on these two equations, I am getting the conclusion. So what are the conclusions? Once you have to see what are the conclusions, first you have to take, let you have to consider two events are simultaneous in S frame, you have to take. What are the expressions? Once you have to see, x2 dash minus x1 dash is equal to gamma into t2 minus t1, t2 minus t1 in minus v into x2 minus x1. This is the first equation, correct? So sorry, x2 minus x1 into, right, which one it is, x2 minus x1, x2 minus x1 into minus V into T2 minus T1. This is the first expression. Similarly, T2 dash minus T1 dash is equal to gamma into T2 minus T1, gamma into T2 minus T1, V by C square into x2 minus x1 we have to take, x2 minus x1. So, based on these two expressions, what we have to take, so let you have to consider, let two events are simultaneous. Here I am taking, let two events are simultaneous. Let two events are simultaneous. You have to consider as a, let two events are simultaneous. In which frame we have to take? In S frame. Let two events are simultaneous in S frame. Therefore, so if it is S frame means two events are simultaneous, S frame means T2 minus T1 is equal to 0, because T2 is equal to T1, because T2 is equal to T1. So, therefore, so once you have to see, if two events are simultaneous in S frame means T2 minus T1 is equal to 0 or T1 is equal to T2 in S frame. S frame they are simultaneous, because in the same time the two events are occurring, right. But you have to observe in S dash frame, T2 dash minus T1 dash is equal to gamma into T2 minus T1 is equal to 0 minus V by C square into, which one we have to take it as x2 minus x1. Therefore, in another frame, if another frame, what you have to write, it is in another frame, not simultaneous in S dash frame, Once again you have to see, if S dash frame not simultaneous, but in S frame is a simultaneous. Suppose you have to take in S frame, T1, T2 is occurring in the same time. So, x1, x2, e1, e2 events are occurring in the same time in S frame, but in S dash frame is the time is different, because T2 minus T1 is not equal to 0. If T2 dash minus T1 dash is not equal to 0 means it is not simultaneous, not occurring in the same time in S dash frame. So, that is why what we have to write, two events which appears to take place simultaneously to an observer are in general not simultaneous to another observer in relative motion. Clear? So, now suppose one more note you have to take. So, what is that note? One more note, if you have to consider the one more note, let you consider if x1 is equal to x2, you have to consider. x1 is equal to x2 we have to consider. If x1 is equal to x2, then what we call those events? Those events we call it as a co-local events. Therefore, if x1 is equal to x2, two events are called, so two events are called co-local events. Which events? These are co-local events. These events we call it as a co-local events. This is very, very important. You have to see, these events we call it as a co-local event, right. If x1 is equal to x2, two events we call it as a co-local events. If x1 is equal to x2, what we have to take? x2 minus x1 is equal to 0. Therefore, if x2 minus x1 is equal to 0, you have to substitute there. So, what will happen? Therefore, T2 dash minus T1 dash is equal to 0 into something is equal to 0. So, therefore, if it is co-local, what will happen in another frame also? It is simultaneous, right? Simultaneous. So, if it is co-local, it is simultaneous. So, therefore, simultaneous in S dash frame. So, in one frame, that is that must be simultaneous. Corresponding to other frame, you have to observe those 2 points must be co-local. Co-local means those are not two events, those must be single event. Then only we have to take it as a simultaneous in S dash frame. So, therefore, simultaneity is not absolute. Simultaneity, what we have to write the conclusion. This statement is very, very important statement. Simultaneity is not absolute. Simultaneity is not absolute means not same in S frame, in S dash frame. Simultaneity is not absolute and but relative. Simultaneity, what it is? Simultaneity is the relative with respect to other frame, right? Simultaneity is not absolute, simultaneity is relative. Therefore, there is no absolute time which is different for observers in relative motion. There is no absolute time in different different for observers in relative motion. That is very, very important observation you have to see. So, based on this, how the questions will come in your competitive examination once you have to see. So, maybe the space time coordinates for two events in S frame are, so two events are there in S frame. What is the data is there? That data you have to write first. What is the S frame is there? Event 1 you have to take here, event 2 you have to consider here. In event 1, so what is the x1 is equal to, they are giving as a 24 meters. In event 2, x2 is equal to which one you have to take it as a 48 meters. 48 meters. Now, the T1 is equal to in S frame only 8 into 10 to the power of minus 8 seconds, and T2 is equal to how much they are giving, 4 into 10 to the power of minus 8 seconds they are giving. So, in event 1, x1 is equal to 24 meters, T1 is equal to 8 into 10 to the power of minus 8 seconds, x2 is equal to 48 meters and T2 is equal to 4 into 10 to the power of minus 8 seconds. Find the velocity of S dash frame such that the two events occur simultaneously in S dash frame. The two events occur simultaneously in S dash frame matlab, so T2 dash minus T1 dash is equal to 0. T2 dash minus T1 dash is equal to 0. How we wrote? Two events occurs simultaneously in which frame? Simultaneously in which frame? Two events occur simultaneously in S dash frame. So, the two events occur simultaneously in S dash frame, we have to consider as a T2 dash minus T1 dash is equal to 0. So, therefore, what we have to write here, once you have to see, find the velocity of the S dash frame velocity. V is equal to how much they are asking. What is our formula? Once you have to see, our formula is T2 dash minus T1 dash is equal to gamma into x2 minus x1 minus v into, which one we have to take it as a v by c square into T2 minus T1. This is our formula, fundamental formula. Which formula we have to take? So, sorry. So, this is the T2 minus T1, correct? So, gamma into T2 minus T1, T2 minus T1 minus Vx by, so x2 minus x1. x2 minus x1. Now you substitute the value. So T2 minus T1 is equal to 0. So gamma is equal to 1 by square root of 1 minus v square by c square. Gamma is equal to 1 by square root of 1 minus v square by c square. You have to take that value, right? So into, we have to take it as a, which one you have to write, T2 minus T1. So T2 is equal to 4 into 10 to the power of minus 8 minus, so T1 is equal to, which one we have to write, the T1 is equal to minus 8 into 10 to the power of minus 8, right, minus v by c square, v by c square into x2 minus x1, x2 is equal to 48 minus 24. This is the submission technique. Once you have to submit the value, so what you are getting, once you have to see 0 into something is equal to 0. So now you have to take it as a minus 4 into minus 4. So we have to take that minus 4 into 10 to the power of minus 8. So now minus v by c square. So v by c square into, which one we have to write here, 48 minus 24 we have to take. So therefore what we have to write, this minus you have to come to this side, 4 into 10 to the power of minus 8 is equal to v by c square into 24. So 24 is equal to, so what we have to take it is, you have to consider here, right, we want to get the value. So 4 6 ja 24. So now you have to take it as a v is equal to, which one we have to write, once you have to see, v is equal to what we have to write, for 6 ja you have to take, here I am taking, once you have to see, here I am taking v is equal to the 6 will go to this side, c square into 10 to the power of c square into 10 to the power of, we have to take as 10 to the power of minus 8 is divided by c, 6, 10 to the power of minus 8 is divided by 6 we have to write here. So v is equal to, c is the light velocity, 9 into 10 to the power of 8 means 8 square, 16 into 10 to the power of minus 8 is divided by 6. So therefore v is equal to, so 10 to the power of 8 it will come, minus 8 plus 16 it will come. So 2 3 ja 3 2 ja 3 3 ja, so therefore 3 by 2. So 3 by 2 is equal to, now 3 2 ja 3 3 ja, so 3 by 2 is equal to, we have to get it as a 1.5 into 10 to the power of 8. So 1.5 into 10 to the power of 8, 1.5 into 10 to the power of 8. So 1.5 into 10 to the power of 8 meter per second, we have to take it as a meter per second. This one we have to consider as a, another one also you have to consider, once you have to see 1.8 v is equal to 3 by 2 into 10 to the power of 8 meter per second. So therefore v is equal to 1 by 2 into 3 into 10 to the power of 8 meter per second. So this 3 into 8 we have to take it as, based on the answer you have to bring. So this one is the c, meter per second. So therefore 1 by 2 is equal to 0.5 c meter per second also we have to write. Clear? So like this also we have to do. Based on your answer you have to able to practice the question. Like these questions we will get in our competitive examination. Not only this, one more question also you able to see. So what is that question? Once you have to see, an event 1 occurs at x1. Suppose you have to take here the data, first you have to write the event 1 occurs at x1 is equal to 20 centimeters, at x1 is equal to 20 centimeters. T1 is equal to how much they are giving, 2 into 10 to the power of minus 8, 2 into 10 to the power of minus 8 seconds, and event 2 is occurring. So, what that x2 is equal to 60 meters and T2 is equal to how much, 3 into 10 to the power of minus 8 seconds, 3 into 10 to the power of minus 8 seconds in S frame. In which frame? So, these things are occurring in S frame. Once you have to see, these things are occurring in S frame. In another frame is there S dash frame. Once you have to see, in another frame S dash frame is moving with x axis, with with velocity v is equal to 0.6 c. So, S dash frame is moving with velocity along the x axis, with 0.c. So, first they want to calculate, this is the data. After taking the data, what they want to do, what is the spatial separation, what is the spatial separation of the events in S dash frame? x2 dash minus x1 dash is equal to how much they are asking, x2 dash minus x. This is the spatial separation. Which separation it is? Spatial separation. What is the spatial separation they are asking? Next, second one, what we want to calculate. So, what is the time interval between the two events in a S dash frame? T2 dash minus T1 dash is equal to how much? So, time interval between the time interval in S dash frame, time interval in S dash frame. So, this is our objective. How we have to calculate? Once you have to see, the first one we have to calculate. How we have to calculate the first one? The spatial separation is equal to, what is a spatial separation? The spatial separation, spatial separation x2 dash minus x1 dash is equal to, in S dash frame, correct? Spatial separation in S dash frame. So, x dash is equal to gamma into, so x minus Vt, that is the x2 minus x1 minus V into T2 minus so T1. All the values are there. You have to substitute x dash is equal to, what is the spatial separation? Gamma into x2 minus x1 minus V into T2 minus T1. So, x2 minus x1 only they want to calculate. So, gamma means 1 by square root of 1 minus V is equal to 0.6 c whole square is divided by c square V square by c square into x2 minus x1. x2 is equal to 60 minus, so which one they are giving? 60 minus 20, 60 minus 20 minus V is equal to 0.6 c. T2 minus T1 is equal to, T2 is equal to 3 into 10 to the power of minus 8, 3 into 10 to the power of minus 8 minus 2 into 10 to the power of minus 8. So, minus 2 into 10 to the power of minus 8, this is the T2 minus T1 value. So, based on this you have to calculate the value. So, you are able to get it. So, how much value you have to get? So, once you have to take this value, so 1 by 0.8 you have to get it, this one. So, this is equal to 60 minus 20 is equal to 40 minus 0.6 c into 1 into 10 to the power of minus 8, 1 into 10 to the power of minus 8. So, therefore, 1 by 0.8 into 40 minus 0.6 c is equal to 3 into 10 to the power of 8 into 1 into 10 to the power of minus 8, 10 to the power of plus 8 minus 8 get cancelled. So, 1.8 it will come. So, 1.8 you subtract and you do this, how much value you are getting. So, you have to get that value. So, how much value? So, you have to get that value 47.75 you have to get, 38.2 you are getting that one. So, once you have to take, this is the value you have to see how much you are taking. 40 minus 38.2 is divided by 0.8. 38.2 is divided by 0.8. You have to see, you calculate. So 382 is divided by 8. You have to do 2 4 ja, 2 1 ja, 2 9 ja, 2 1 ja, 191. Now 4 1 ja, mm, uh, 47, right, 47.75 you are getting, clear. So this is the spatial separation. How much calculated you have to do. The same way we have to calculate. So time interval in S dash frame. The second one you have to see, T2 dash minus T1 dash is equal to gamma into, so gamma into T2 minus T1 minus V by C square into x2 minus x1, x2 minus x1, T2 minus T1 minus V by C square into x2 minus x1. Therefore T2 dash minus T1 dash is equal to gamma is equal to 1 by square root of 1 minus V square by C square. So which is equal to T2 minus T1 minus V by C square into x2 minus x1. So bracket close. Now you substitute the values, 1 by square root of 1 minus 0.6 C whole square is divided by C square into T2 is equal to 60 minus 20 minus V by C, V 0.6 C is divided by C square, x2 minus x1 is equal to not 20 minus, this is the 60 minus this one is a 60 minus 20. This one you have to consider as a 60 minus 20. This one you have to take it as what is that? So 3 into 1 into 10 to the power of minus 8. You simplify, you able to get the answer. So what is the answer you have to get? Minus 8.75 into 10 to the power of minus 8 seconds you have to get. Once you check this, right, like this we have to do in our competitive examination. So simultaneity is very important. So please concentrate whatever I am teaching. So things daily one topic only I am teaching. If I teach all the applications, length contraction, time dilation, mass variation, energy mass equivalence, if I have to teach in the single class, you unable to memorize, you unable to remember. That's why I am splitting the topics, I am dividing, I am teaching to you. Why I have to take like this? No, because it is my institute. How many hours I want to teach, I have to teach to you. So that's why I am taking. So please utilize the chance and learn the subject and habituated to practice it daily. So then only you able to perfect in your competitive examination. Otherwise no one can get perfect. Thank you so much. Thank you. Please concentrate and practice it. Thank you.